Good evening. So today I come up with one more video, and here in this program I will explain the concept of shallow copy. So if you concentrate on the file name, so you will see four shallow copies. So you will be wondering what is shallow copy and how will we use it in Python program, and if shallow copy is not there, then what will we do? Then how we will use this concept? Like if the shallow copy is not there, then what is the difference it makes in this program? So you will see this program consists of two cases. If you concentrate, this is the case 1 and this is the case 2. Okay, case 1 dealing with the single list object and case 2 dealing with the nested list. I will come to the nested list part later on. First of all, I will explain the case 1. So you will see at top we are importing an inbuilt Python module, that is copy, for performing some different Python copy functions. Sorry, for performing different copy functions. That is copy.copy, and there is another function called copy.deepcopy. I will explain the concept of deep copying later videos, not in this video. So coming to the case 1. So in case 1, what I have done, I've created a reference of class type list. Okay. Means not creating, I'm declaring a reference of class type list, and I'm here in the line number 6, I'm initializing the reference by using three elements, that is 1, 2, 3. Okay. So I've created a list object inside a memory. Now what I am doing next, here I've created another reference of type list and I'm assigning original reference into this. Okay, that means both the reference variable, sorry, both the references original and duplicate with pointing points to the same list object. See, original and duplicate, I've tried to like create an image here only. So this is the original reference and duplicate reference, and both are pointing to the same list object. And I will prove it, like I've printed the address of both the reference original and duplicate, and also I've compared the address of both the references, so that it will be clear that both the references are pointing to the same list object. So let's see by running, by executing this program. So Python shallow copy.py. If I press enter, you will see this will return a boolean value that is true, because both the addresses are same. Both the addresses are pointing to the same list object. See, both the addresses are same. So it is proved that there is single list object inside a memory and both the references are pointing to the same list object. Okay. Now I have not used copy.copy function here. Now if I use copy.copy function, I will uncommand this, and then I will uncomment it. Though most of the part is commanded, you will be wondering why it is commanded. I will uncomment in when I required. Okay. So now in the copied part, so now here if you see I've used copy.copy function. So now what is copy.copy function? Copy.copy function, when I have created another list object, sorry, another reference of type list, and I've assigned, sorry, and I've used copy.copy function of original, and I've passed original reference. So what it does now, it is not the single list object inside the memory. Now this copy.copy function also creates a new list object inside the memory. So both the list are independent. So both are pointing to the different list object. Original is pointing to different list. I have also created a diagram. So original is pointing to the different list object and copied is pointing to a different list object, but both the elements in both the list are same. Okay, copy.copy function creates a new list object. So this is the difference between when I assign the original part into the duplicate, then both of the references are pointing to the same list object, but by using copy.copy function, we have created another new list object, okay, inside the memory. Now I will prove it when I've done the same here. When I will print the addresses and compare the addresses, you will see it will provide false. Now let's see whether it is provide providing false or not. See, it is providing false. And the address are different because the address are different because both the references are pointing to the different list object. Okay, now I will prove it by modifying an element inside the list through a particular reference. Like through original reference I will modify one element inside the list, and you will see it will not reflect to the copied part. Okay, now let's modify it. Right, net uncommand this. Now I've commanded it. Okay, uncommanded it, and now I'm modifying through original reference. I'm modifying the first element. I'm modifying this one first element. Okay, with triple one. Now after modification I will print the both of the list, both of the independent list, which is stored inside the inside different memory locations. Okay, now what you will see through the original, though I've modified it through the original reference, it will reflect in the original part. You will see it is modified, it is reflect in the original part, but in the copied part the same list will be there. Okay, you will see when I will run, you will see the original part is modified but the copied part is not modified. It proves that both the list are stored inside the memory separately, means both lists are independent. Okay, now let's come to the next case 2, that is this case deals with nested list. So now you will be wondering what is nested list. Nested list is a list inside a list, means now in the same way I'm creating a reference original, okay, of type list, and we are creating a nested list, means it has a outer list and two inner list inside the outer list. Now again I'm creating a reference of type list and I'm using copy.copy. Now what copy.copy does, it creates a new outer list. Okay, the outer list are independent, it creates a new outer list. That copy.copy function creates a new outer list, but the inner list are shared. If you see this diagram, original copy, only the inner list is shared, means you will see I have printed the address also. You will see the address of both the address through both the references original and copied are different, but the inner list is shared. Inner list is shared means whatever values, whatever is there inside the outer list, inside the outer list, these two inner list will be shared. It will be there in the copied part also. Okay, now if you see it will provide the, if I like run this program, you will see the address are different because the outer list is different. Here the outer list is different, okay, but the inner list is same. I've modified it, that's why you are like wondering. Now if I run it, you will see the outer list is different, that's why both the address are different. See, both the address are different. Okay, now I will prove it that the inner list is shared by modifying an element through one of the references. Now let's modify it. I've uncommanded this. Then here I'm modifying. Okay, like I've provided two index, original. Through original I'm modifying. Okay, the first index refers to the first list, and the second index refers to the first element in the first list. Okay, I'm modifying this one. Okay, if I modify this with 999, you will see I've printed, after modification I printed the list through original reference also and copied reference also. You will see the address are different, still address are different, but you will see the modification reflect, means the updation is reflected through both of the references, through the original also, through the original reference also, and through the copied reference also. Let's run it. Now you will see, first of all it will provide false, the upper part. Now you will see after modification, see these are the both the list. Okay, both of the lists, show both of the reference. Okay, you will see I have updated this element. This is the original part. This is the list of the through original reference. It is updated, and also the copied part also updated. That means the inner two lists are shared through both the references, but the address are different. See, it is providing false, the address are different. That means the outer list is only copied. The outer list are created newly, but the inner list is shared. This is the behavior of a shallow copy. It does not copy everything. It just copy the outer list, but the inner list is shared. Okay. So copy.copy by default does shallow copy. For deep copy, we need to use copy.deep copy. This deep copy concept I will explain it in my later videos, or else the video will be long. So that's all for today. And I forgot to tell one thing in my last video, that is, if you have any questions or query or any suggestions for me, or if I have done anything mistake, just let me know in comments. I will concentrate on those comments and try to rectify my mistake. Okay, so that's all for today. uh, I will The next video will be very soon. So till then, bye bye.